usual, please go to the tasks to complete list for today. This is Unit 1, Lesson 9. So you can either go to the Canvas homepage and look at the weekly calendar or look under assignments. You're looking for tasks for U1L9. First thing I wanted to do was review the homework. You should have submitted an image of the planets to scale. And make sure you color it in as well. That's going to be a main part of it. I know some people submitted it not colored. I'll send a note back and you can resubmit an image of it colored in. I'm just uploading my gradebook here to make sure things are up to date. And you're welcome to go check out your grades tab. I have entered scores for pretty much everything now. So Matthew, Bryce, Lena, Aiden, and Eric, I don't have images for you yet for the drawing the planets, so please get that done and submit it as soon as you can. And then as usual, you need to have submitted notes for presentations 3 and 4, which hopefully you did right after the presentations were done. Again, there are a few people who still need to do that. Ronan, you should submit your notes. Let's see. Bryce for number 4. Camille needs to see your notes submitted. Grace Kirsch and Noah just for presentation 3. And Aiden again for both presentations. So again, you can go to the gradebook and check those out, but I'm going to try to stay a little more up to date if I can. Anyone have any questions or need help on any of those homework assignments? Great. Our goal today is just to continue presentations, but like we did last time, let's see what you remember. We have now learned about the inner planets and the outer planets. So we're going to do a short quizzes, which is essentially just like Kahoot on the planets. And let's see what you remember. Again, this isn't graded or anything. This is just some fun facts. Let's see what we pick up. My second time using this, but oh, oops. Okay, so you should be able to join, go to joinmyquiz.com and enter the code 445683. And please use your own name or something close to it. And we've got 15 people in the class, so I'll wait till we're at 15 or close to it. All right, I think even when, I'm gonna go ahead and start it because most of us are here, we're still waiting on one person. But if you are still trying to join, I think the join code stays on the lower part of the screen. So let's give it a go. The largest planet in our solar system is? All right, Brandon in the lead. Did we get to see the right answer there? Oh yeah, there we go. Very good. All of you, almost all of you got that it is indeed Jupiter. Which planet is closer to the sun than Earth? All right, Ronan in the lead now. Bryce close behind. Very good. It is Mercury. Again, think Venus and Mercury are the only two that are between the Sun and Earth, those inner planets. The red planet. This is an easy one. All right, Ronan's still in the lead. Camille catching up. Very good. It is indeed Mars. Appears red. It has iron in its soil, rusting. The planet with the most spectacular rings of any planet is. All right, Ronan's still in the lead. It is indeed Saturn. However, remember that they all actually have rings. It's just that Saturn's are the most visible. What is the correct order of the planets from the Sun? All right. Ronan going strong. It is indeed Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. I often think the last three planets spell out Sun, S-U-N, and then you kind of, there's other little anagrams you can use. Halfway through. It is indeed Jupiter. Again, think of the gas giants being the outer planets. What is the hottest planet? Bit of a trick question here. All right, someone's got to catch up to Ronan. Venus is actually the hotter of the planets, even though it's the second closest. And remember, we learned that's because of all the carbon dioxide in its atmosphere. Which planet orbits on its axis sideways? It's a bit unusual. Uranus is rotating on its side. It's very unusual. And the rings are actually going that way as well. Which two planets spin at roughly the same rate? This was mentioned in the presentation. Mars and Earth, even though they're very different sizes and have different kind of core densities, the time period for rotation is similar. Last question. While the inner planets are solid, the outer planets are? It's kind of a repeat question. All right. Looks like Ronan was our final finisher, and they are gaseous. And I guess there's no leaderboard celebration like there is on Kahoot, but let's see. Oh, no, it does see that. Here we go. All right, way to go, Ronan. Eric in second, Sophia in third. Nicely done. All right. Any questions or comments on that? It's like we're feeling good about the planets. Next thing I wanted to look at really quickly was the feedback that I got. You all filled out the end of September survey. So just to share a few things. In terms of how things are going, looks like we're on the higher end of engagement, which I'm happy to see and hopefully we'll continue to do. For homework, it looks like most of you feel like it's just enough, though some of you feel like it's a little too much, so I will keep that in mind and try to modulate the load as much as possible, especially in terms of reading. It does seem like the time spent on homework ranges from anywhere from 20 to 30 minutes to 1 to 2 hours, so that is definitely inconsistent in terms of how we're feeling about how much time we spend on the homework. In terms of pacing, everyone's feeling good so far. A little bit of inconsistent, a little bit of too fast. So again, I will try to err on the side of slowing down when I can, especially when we have our first assessments coming up. We'll try to review. Looks like most of you would like to try to get away from computers every now and then, so we will continue to try exploring Flipgrids or something like that that we can do away from the computer. And I got some good feedback from you, mostly just it's summarized there in the tasks to complete list about using Edpuzzles, Kahoots, Quizzes is another program, the one we just used, using breakout rooms, and giving breaks in the middle of class when possible. So those are things I will keep in mind. So I really appreciate a lot of your honest feedback on that. Okay, then without further ado, let's start our presentations. Today we are going to hear about life in our solar system from Tristan and Ronan, and then about Earth's moon and eclipses from Grace Kim and Matthew. Tristan, Ronan, you feeling ready to go?
Yep.
All right. As usual, you are expected to be taking notes, so everyone needs a notebook or piece of paper in front of them. The first presentation is Life in Our Solar System by Tristan and Ronan, so make sure you're ready to take notes on that. You will be submitting a photo of your notes for an assignment. Tristan and Ronan, how you want to do this? Does one of you want to share your screen, or do you want me to do it?
I can share my screen.
You got it? Okay, I'm going to make you a co-host, so you have screen sharing capability. And again, I will time at 15-minute mark. I'll just give you a little warning. But yeah, hopefully most presentations have been going about 10 minutes or so.
Should I share it?
Yep. Mm-hmm.
Okay, so our project was on life in our solar system, Mars, Enceladus, and Europa by Tristan Evans and Ronan Bennett.
Tristan, you feeling ready?
Yep.
All right, let's do it.
All right, so what is the habitable zone? The habitable zone is a region of our solar system, not too close, but not too far from the sun, where surface water can exist in its liquid form. So this is also called the Goldilocks zone. And all known life needs water to survive. So if we were to find extraterrestrial life in our solar system, it might be in the habitable zone.
And as Eric elaborated for us, why do you think it's called, what do they mean by Goldilocks zone?
It's like not too cold, but not too hot. It's like just right.
Yeah.
All right. What are the conditions required for extraterrestrial life? The most important thing for extraterrestrial life is water in the liquid form, and then a source of energy, the elements of biomolecules, and stability. So that goes along with the Goldilocks zone, not having too hot of weather or too cold of weather.
Yeah. So first is water. All known life forms need water to survive because it's essential for life. And liquid water is most optimal because it transfers the nutrients required for life like most efficiently. Europa and Enceladus, both moons in our solar system, have been found to have water and ice on each moon, but neither of them are in the habitable zone. So they're not going to have surface water, but deep under the icy surfaces, the core of each moon could heat the water to its liquid form. And so scientists like think that there could possibly be life under each of the icy surfaces.
Okay. Every living source or every living thing needs a source of energy. Plants on the surface of Earth get their energy from the sun using photosynthesis. That energy gets transferred to the animal that eats it. Deep underwater, it is difficult for sunlight to reach the organisms in order to do photosynthesis. Instead, they use chemosynthesis, which is certain microbes that have chemical reactions to create energy.
Yeah, it's very similar to photosynthesis, but they're basically using heat and sulfur to make sugars. Yep.
If there were extraterrestrial life forms in our solar system, they'd likely be getting energy through photosynthesis, chemosynthesis, or some other chemical reaction to generate energy.
So kind of a cool
All right,
breakthrough because they used to think life could only exist where light was, but chemosynthesis shows that you don't necessarily need light to have life. Sorry for cutting you off,
yeah.
Ronan.
All right, so there also has to be abundant in carbon with other elements such as hydrogen, nitrogen, and oxygen. Because carbon has the ability to bind as many as 4 atoms at a time, which allows it to create a multitude of complex molecules that would be necessary for stable life. With carbon, hydrogen, nitrogen, and oxygen, you can combine them to create biomolecules. Biomolecules are an organic molecule that includes carbohydrates, lipids, nucleic acids, and proteins, which are key for the survival of living cells.
A planet cannot carry life if it is constantly being hit by asteroids or constantly having huge volcanic eruptions. Life needs time to grow, multiply, and evolve. If it is constantly being wiped out, it is likely that life won't last long on a planet or a moon.
What is the Drake equation? The Drake equation, proposed by astronomer and astrophysicist Frank Drake in 1961, is used to estimate the number of extraterrestrial communicating civilizations in our galaxy by multiplying numerous variables. The variable n is the number of civilizations in our galaxy whose electromagnetic emissions are detectable. Variable r is the rate of formation of stars fitted for the development of life. Fp is the fraction of those stars with planetary systems. Ne is the number of planets per solar system with an environment suitable for life. Fl is the fraction of suitable planets on which life actually appears. Fi is the fraction of life-bearing planets on which intelligent life emerges. And Fc is the fraction of civilizations that develop a technology that produces detectable signs of their existence. And L is like the length of time such civilizations produce such signs. And not all of these variables have been like discovered yet, so we don't know the values for each variable. So we don't have an accurate answer for n.
And one of the reasons why it's so difficult to live on Mars is due to acidic fluids that float on the planet's surface. And these fluids probably destroyed evidence of biological life. However, recently 2 Italian scientists discovered there were underwater lakes on Mars, and they believe the conditions in those lakes could be suitable for life.
Okay, so each of these movies are accurate depictions of humans in space and on other planets. The First Man is a look at the life of Neil Armstrong and how he like on their mission to get to the moon. The Martian is about an astronaut who is left behind by his team, and like he's stranded on Mars, and it's about him getting home. And Interstellar is about a team of astronauts traveling through space to save Earth. That's all. That's our presentation.
Nicely done. All right, let's unmute ourselves. Round of applause, please. All right, how many people have seen The Martian? I think I asked this earlier when we had our Mars presentation. Quite a few, at least half the class. How many people have seen Interstellar? Christopher Nolan movie. Interstellar is fun because unlike The Martian and a few other things, it really plays with the whole time relativity thing. If you've seen that movie, that's what most of that movie is actually about. How many of you have seen First Man? Be honest. This is one I think not a lot of people checked out. Nice. First Man's a great one if you're curious at all about moon landing stuff. I had no idea. I didn't know much about the life of Lance, not Lance Armstrong. But he, anyway, it's a well done movie and really cool moon scenes. So, all right, questions or comments for these guys on life in our solar system? Okay, be totally honest. How many of you think there is life out there? It doesn't have to be intelligent, but just do you think there's life on other planets other than Earth? Nice. All right. Got some optimists here. That's essentially what the Drake equation's getting at, which Ronan, you did a good job breaking that down. Pretty nuts. That I mean, some of those variables. It's like how do we know? Like how do we know how many planets there are that are out there? But anyway, I mean, they're just taking their best guess. But I mean, they are. It is even though they're not sure about some of the variables and they're just guessing at half the stuff. It's safe to assume that n is probably greater than 1, which means that aside from us, we're probably not alone. Now, does that mean it's just bacteria that are living on a planet? That's probably true, and I know that doesn't sound very exciting, but I think for astrobiologists, which are the people that study life outside of our planet, that's very exciting. Again, everyone's just trying to figure out the main thing is that if there is life on other planets, does it have DNA and RNA, which is what all life on our planet is based on. It's this kind of molecular code that we have. And so is that something that is universal, or is it just something unique to Earth? Ronan, you made a good point too about how carbon is kind of one of the key elements because it builds such large compounds. On the periodic table, if you look below carbon, there's another element that has very similar properties, which is silicon. It's just that Earth doesn't have the right conditions for silicon to be like an organic substance, really. But it's possible that maybe on other planets you could have like a silicon-based life form. I don't know. That's what people really kind of speculate on a lot. So, other questions or comments? Cool. All right. Good job, guys. All right. Then our next group is the moon and eclipses with Grace, Kim, and Matthew. Grace, Kim, Matthew, you feeling ready to go? All right. So everyone taking your notes, make sure that you now title it The Moon and Eclipses. This is going to be Grace, Kim, and Matthew Choi. Grace and Matthew, how do you want to do this? When do you want to share your screen? Do you want me to do it?
I can share my screen.
Okay, I'm going to make you a co-host.
Do we start?
Yeah, if you're feeling ready. And I think everyone's should be good with their notes, right? Then we can go for it.
So this is the Earth, Moon, and Eclipses by Grace, Kim, and Matthew Choi. Next. So what is the giant impact theory? In the mid 1970s, the researchers proposed the giant impact theory, and the giant impact theory is a speculation that an asteroid roughly the size of Mars impacted the Earth during its formation, and this resulted in surface material being blown up from Earth, which led to the formation of the Moon, as you can see in the picture above. So next, it's successful moon landings, and in total there are 21 successful landings, including both robots and humans, and 12 humans have set foot on the moon, which is Neil Armstrong, Buzz Aldrin, Pete Conrad, Alan Bean, Alan Shepard, Edgar Mitchell, David Scott, James Irwin, John Young, Charles Duke, Gene Cernan, and Harrison Schmidt.
Nice. Most people have only ever heard of the first two.
Next. So the Earth has two eclipses, the lunar and solar. And basically, a lunar eclipse is when the Earth gets in the way of the sun hitting the moon. That means during the night, a full moon fades away. And a solar eclipse is when the moon gets in the way of the sun's light and casts a shadow on Earth. Furthermore, during a lunar eclipse, Earth gets in the way of the sun's light hitting the moon. That means that during the night, a full moon fades away as Earth's shadow covers it up. The moon can also look reddish during a lunar eclipse because Earth's atmosphere absorbs the other colors while it bends some sunlight towards the moon. Sunlight bending towards the atmosphere and absorbing other colors is also why sunsets are orange and red.
Yeah,
And
anyone ever heard of a blood moon? That's how they often refer to it, is when the moon appears kind of reddish. And yes, you hit it exactly right, that it's basically like the sunset colors we normally see on Earth are being reflected onto the moon.
and a solar eclipse is when the moon gets in the way of the sun's light and casts a shadow on Earth. A total eclipse happens about every year and a half somewhere on Earth. A partial eclipse is when the moon doesn't completely cover the sun, and it happens at least twice a year somewhere on Earth. Next. So how does the moon affect the ocean? So the moon has a gravitational pull that generates a tidal force, and the tidal force causes Earth and its water to the side closest and farthest from the moon. These bulges are high tides, while the non-bulge parts of the Earth are called low tides. Yeah.
Okay, so moon landing speculations. A lot of people believe that the Apollo 11 moon landing was fake. It is because no stars in the background support that the moon landing never happened. For example, the flag seems to be flapping to the wind, even though there is no wind in space. The phases of the moon. The phases of the moon are the different ways the moon looks from the Earth over about the month. The four main phases of the moon are the new moon, first quarter, full moon, and third or the last quarter. The rotation period of the moon is about 27.3 days. The cultural and religious significance of the moon and eclipses are, according to the Hindi mythology, eclipses are the bad omens. However, in Western and Chinese culture, the moon represents feminine energy. In the ancient Greeks, they believed that the eclipses are the punishments. It is because the word eclipse is derived from the Greek word meaning disappearance. Lastly, Christianity refers to the moon as a symbol to highlight cosmic events. And these are the photos and videos of successful moon visits by humans. And we're done.
Nice. All right. Can you go back one slide just to the images you had? So, any stars in the background?
No?
Fake, right?
Fake.
None of these moon landings ever happen. This is something part of your homework will be a little bit of an assignment. So, is that a video on the one side that you wanted to show?
Yeah.
Okay. See if we can pull it up. Maybe not show the whole thing, but do you know what part of it you want to watch? We might need your computer's audio. Like you're gonna have to, yeah, turn it up.
Oh, you won't believe it. There goes a fender. I caught it with my hammer and it just popped right off. Okay, was it the roof fender, Dino? Yeah, and I'm just gonna.
So is this footage of one of the Apollo missions, I assume?
American gray tape on it. Chopped out the old-fashioned American gray tape doesn't stick to lunar dust-covered fenders. Jack Schmidt on his way back to the lunar module. I was rolling on the moon one day in a merry, merry month of December. Now, May days to May. That's right. Da-da-da-da-da-da-dee.
You can kind of see the funny way they're walking because of the lower gravity.
Crew's using maps to make that fender. We gotta take a picture of that fender if it works. I want the help truck. I'll be there. I don't need any help. Can I change your oil? Okay, wait a minute. What? Where are the reflections? I've been fooling. There is orange soil. Well, don't move it till I see it. It's all over. Orange. I can see it from here. It's orange. It's crazy. It's been oxidized. It looks just like an oxidized desert soil. That's exactly right. This is Apollo Control. Gene Cernan and Jack Schmidt aboard Challenger on the lunar surface. Ron Evans aboard the command module in orbit around the moon. This is America. Hello, America. Time to turn the recorder on. Recorder on. Recorder's on. Okay. Where are the guys on Challenger? Are they going to go out regular time? We're planning on ascent at the scheduled time. Okay. As Ron Evans doing his orbital science task and orbital photography. Less than a minute away now as Cernan and Schmidt aboard Challenger on the lunar surface are awakened for the third moonwalk. If I may, I'd like to remind everybody this valley of history has seen mankind complete its first evolutionary steps into the universe. No more significant contribution has Apollo made to history. And I think everybody ought to feel very proud of that fact.
Cool. Yeah, you can probably stop it there. Yeah, so that was one of the later Apollo missions. Those guys did the most lunar walks. They did 3 days. Whereas like Neil Armstrong and a lot of those guys, when they first landed, they only went out once. And then they went back and traveled back. So pretty cool. Yeah, we'll do a little assignment where we'll be reflecting on the authenticity of some of those. But how American of a thing for us to go to the moon? And did anyone see what they had parked over on one side? What did they bring up to the moon to use? Did anyone see it? They were fixing the fender with duct tape. It's a little. It's a car. There's no more American thing to me than to take a car up to the moon and drive around. But you could see a lot of what they were doing was digging holes, taking soil samples, rock samples. A lot of that was brought back for study. And so, yeah, I mean, kind of just concluded that, as you mentioned with the giant impact theory, most of the moon's composition is very similar to Earth, like definitely probably came from Earth, and is largely lifeless because there's just no atmosphere. So nice job. Let's everybody unmute yourselves really quick. Round of applause for our group here. I liked your cultural significance stuff. The one thing too that I think kind of slips through the cracks is Islam. Muslims are actually very lunar-based religion as well. If you've ever been to a mosque, they often have a crescent moon as part of their symbol. And a lot of the phases in that religion, especially Ramadan, where they fast for a whole month, is all based on the moon cycle, right? They fast for basically one full cycle of the moon, so it's 1 month. But they're very attentive to the moon and its movements, which I think is pretty interesting. So, any other questions or comments for this group about the moon? So, as part of your Matthew, as part of your giant impact theory, are you saying that Earth once had rings temporarily after the impact?
That's what the picture I saw says.
Yeah, yeah. It's kind of weird to think of Earth as having rings, but that's probably what happened. And then it all kind of there must have been larger chunks that started crashing together and got big enough and had enough gravity that they cleared the orbit. So then all the debris ended up in just the one big solid circular moon. How many people here have seen a solar eclipse? Right, meaning the moon has gotten in the way of the sun. Maybe I got that wrong. Maybe that's a lunar eclipse. How many of you have seen that? Nice. Some people go crazy. I know a couple people who literally plan their lives around where certain eclipses are going to occur, and they try to be at those places because they want to see the total eclipse, and they plan their whole lives around it and what they're doing. And again, they happen, like you said, I guess about twice a year, but it depends on where you are on the planet. Some places are harder to get to than others. The U.S. Has actually experienced a couple total eclipses recently, and I think there's another one coming up at some point. So it's worth kind of looking up when that's going to occur. All right. So, well, we've got a little extra time, which is good because we're going to continue to do some lunar exploration stuff because I think the moon is just really, really interesting. So, I'm going to let you go to work on these next couple assignments on the tasks to complete list after the presentation. So I'm looking at step number 7 here. The first is a drawing assignment where I'm actually going to have you guys draw the phases of the moon. You're going to use your compass again to kind of set up a little worksheet. I didn't want to assume that everyone had printers. Plus, I think there's value in just drawing it out completely from scratch. But on a blank piece of paper, you're going to be drawing the Earth, the sun, and 8 circles to represent the 8 phases of the moon. And then you'll be shading them in and labeling them according to the video. So that assignment there, it says drawing the phases of the moon. If you click on that, it'll take you to the assignment. There's instructional videos and everything on how to do that. So you can take some class time to work on that now. If you get finished with that, then you can go on to the Canvas discussion, which is the moon landings discussion. I want to do a quick little claim evidence reasoning on whether or not you think the moon landings were faked or not, and see what resources you can find to support your claim. Doesn't necessarily have to reflect your belief, right? Might be more fun even if you do think they happen to maybe look up the evidence for whether or not they were, if they were faked, the people who said they're faked. Then there's a Flipgrid assignment where you're basically going to be in a dark room with a light, holding a little spherical object and going around like this to actually observe what's going on with the phases of the moon and why the moon appears in the sky as a crescent or as a gibbous and so on. So anyway, but let's start with step number 7 now, drawing assignment, drawing the phases of the moon. And I'll give us about 10 minutes, maybe a little longer, maybe 12 minutes to work on that. And then again, if you get done with the drawing, you can move on to step 8 and step 9 on the tasks to complete list. I'll be here listening if anyone has any questions or is not sure what to do, but otherwise, yeah, let's just take the next, let me do the math on this really quickly. We'll take the next, 11 minutes, let's say, to work on drawing, Canvas discussion, Flipgrid, wherever you can get done. Go for it. Let me know if you need help.
Oh, I kind of don't know where my compass is. Like, I think I lost it.
Okay, you can find just maybe find some small object to trace, like get a, sometimes like a bottle cap or the lid of something, or if you got like a pencil case, you can usually find something. Just make sure it's small enough that you can get 8 of them in a circle on a page.